very good day. So today I would like to explain to you how to conduct experiments of performance characteristic of diaphragm pump. Okay, so before I explain to you how we're gonna run this experiment, I will show to you each equipment each part consists in this experiments. Okay, so first of all, this is the panel box in which that the electric power supply will send to this box. It also consists of flow meter indicator, torque indicator, and speed controller. Okay, the next part is motor. Okay, so this is the motor, and this motor is connected to this diaphragm pump through the shaft here. Okay, this is the acrylic tank. Okay, in which that in this acrylic tank it consists of water. Okay, so when the pump is turned on, okay, the water will come up at the bottom of the tank, and so this is the outlet of the tank, and this is the inlet of the tank on the top of the tank. Outlet pressure gauge. Okay, so if you can see here, in this pressure gauge, okay, the unit is in PSI. So in this experiment, our objective is we want to determine the relationship between the speed of the pump or shaft speed with the torque, flow rate, and pressure of the pump. Okay, and the second objective is we want to know the efficiency of the pump against the flow rate of the pump. Basically, in these experiments, you only need to regulate the frequency of the pump here by adjusting the button at the bottom here. Okay, so as you change the frequency, it will cause the change in torque, flow meter, and the pressure gauge of the pump here. Now I will show to you how to run the experiment. So firstly, you need to turn on the switch on the panel box here. Okay, and wait for a while. Then you can press the green button here, which is labeled as run. Okay, just press the run button. Okay, before we can adjust the frequency here. So based on the table here, our first frequency is 16 Hz. Okay, so now you can adjust the frequency to 16. Okay, this is 16 frequency. Okay, so as you can see that the pump start moving, okay, and the water start to flow. Okay, so and according to the table just now, you have to record the flow meter, torque reading, and pressure outlet. Okay, so okay, there will be a change in torque reading, flow meter, and pressure outlet. For example, in this case, at frequency 16, okay, the torque reading is 0.526. So you have to record the reading of the torque in the top column, 0.526. And the flow rate shown on the flow meter is 7.4. You record in the table 7.4, and pressure reading is we take the reading of pressure gauge from the outlet of the pump. Okay, so inside reading is referred to the reading in a bar, and the outside reading is actually the reading in the unit of PSI. Okay, So we take the reading value in bar unit reading. So if you look at the needles here, it shows that the reading is 0.08 bar. The column bar here, which is 0.08 bar. Okay, so for the next reading, which is at 17 hertz, okay, you just need to adjust the regulator at the bottom here to the value of 17. Okay, so by using the same procedure, you just need to record the flow meter, the torque value, and the pressure gauge reading. Okay, so just proceed the same procedure for other parameters of frequencies. When you're done taking the reading at 5 different frequencies, okay, you need to shut down the equipment. Okay, so in order to shut down the equipment, okay, first of all, you need to set the frequency back into 0 first. Okay, by adjusting the button at the bottom here. Okay, so now the frequency is 0. Then after that, you can just turn off the pressure. You can just turn off the main switch here. When you done the experiment, okay, you might need several data, okay, from the experimental setup in order to proceed your calculation. Okay, especially when you want to calculate the efficiency of the pump. Okay, between the top of the tank until the bottom outlet of the pipe here is actually 545 millimeter. The diameter of the inlet pipe into the pump and outlet pipe into the pump. Okay, so the inlet pipe into the pump is the reading of the diameter is actually 15 mm. Okay, and as you can see here, the size of the both pipe is the same. So therefore, the diameter for the outlet pipe is also 15 mm. Okay, the next parameter is the motor output, or we also call it as a pump input. Okay, so as you can see here, the motor output here is actually 0.18 kilowatt.